Okay, we're going to take some time and look at parallel lines, and so kind of gives away the first part of what we're looking for here. But when we look at these, I have y equals 3x, y equals 3x plus 6, and y equals 3x minus 5. So when we're looking at those, you probably notice that all of these equations have the same slope. And so we say they have the same slope. Then if we graph these lines, what I end up with is see a line that goes through right there, and plus 6 would go through that. And so I'll just graph two of them real quickly here so we can get just a basic idea of how they look. The minus 5 would be down here like this. So looking at those lines, we'd hopefully notice they don't cross. Or that they move up at the same rate. And so when they don't cross or they move up at the same rate, and really it's going at the same rate, it's that they don't cross and they would never cross. That they could go on forever, they'd never cross. And so those are our parallel lines. And so they are lines that are on the same plane but do not intersect. Intersects. Okay, and so the conclusion that we're kind of looking for here is that the equations have same slope, but different y-intercepts. So, because if they had the same y-intercept, they would actually be the same line. So, same slope, different y-intercepts, and we're ending up with lines like that. On most of this, though, we're not going to have a graph here with this, and we're not really deciding if two lines are parallel, because all we're doing there is if we look and say, oh yeah, they've got the same slope, the 3, then we can tell right away those are parallel. What we're looking for is when they give us an equation at a point, to give us the equation of the parallel line that goes through this point. So for this one, we're looking for slope-intercept of a line that passes through this point, 5, negative 4, and is parallel to the line represented by y equals negative 5x minus 8. Well, on this, if it's parallel, it'll have the same slope, but a different y-intercept. So really, I don't care about anything but that slope. So I need a line that has a slope of negative 5 and goes through the point 5, negative 4. So looking at that, I would use my point slope form, which is y minus the y1 value, which is negative 4. So instead of minus a negative 4, we'll just say y plus 4 equals the slope, which is negative 5, times x minus the x value, which is 5. And from there, we're just going to solve it out for y. So I distribute first, negative 5 times x and times negative 5, which gives me a negative 5x plus 25, not 52. So y plus 4 is going to equal negative 5x plus 25. And the last thing I'll do is add 4, or subtract 4, sorry, from both sides. Remember, the negative 5x will stay on its own. And so I get y equals, the 4's are gone, negative 5x plus 25 minus 4 is 21. And that will be our equation there. And it's in slope-intercept form already, so we are good to go. All right, on our next one, we want an equation in standard form that passes through this point and is parallel to this one. So, for parallel, we need the slope, which I don't actually have yet. So, in order to find the slope, let's put this in slope-intercept form, which involves me moving the x term, changing the sign, so I'm subtracting 5x from both sides, which is going to give me 3y equals negative 5x plus 18. And divide everything by 3y, or just by the 3 rather, sorry. That cancels out there. And really I don't have to work the rest of this out because I already have a slope of negative 5 over 3. But we'll finish it out. So we have this. What I'm really looking for is the slope, negative 5/3. We'll plug it into the slope-intercept form. So y equals, or sorry, that should be y minus y1. So y minus the 14. And remember, I'm using this point up here. Y minus 14 equals the slope, which I got, that was negative 5 over 3. And don't worry about the fact that it's a fraction, a weird fraction even. We can, anything we're multiplying or adding, should be able to put that in the calculator and work it out. X minus the x value, which is 6. So the next thing we do, we know what we're doing here. We will distribute the slope to both of those, which gives me negative 5 over 3x. Negative 5 over 3 times negative 6 gives me a positive 10. And all that equals y minus 14. And so to get it in slope-intercept, we add 14 to both sides to get, and I'm going to have to go down here into this next one, to get y equals negative 5 over 3x plus 24. Okay, but it doesn't ask for it in slope-intercept, it wants it in standard form. And this process we practiced a little bit, but what I need to do is get everything as whole numbers. Then I'll move the x term and make sure the front number is positive. So, to do that, I've got to multiply everything by this denominator of 3. So when I do that, it gets me 3y equals negative 5x plus 24. And, oh, not 24. 24 times 2, which would be 72. And then from there, I will move this x value over and change the sign to get a positive 5x plus 3y equals 72. Should be our answer. And so a couple things we notice here. The 5x plus 3y part is actually the same as this up here. Because our slope's the same. The only thing that changes is this number in the back. So, no, we took up the space for 2, but that is our equation for that one. The rest of these, we're going through the same thing. It's finding slope in different ways, so saying plus 4, plus 3. So the slope would be 3/4, and we go through the same process. Use the point slope form and find it from there. Last two I want to look at a little bit. On the one on this side, first of all, when we've got a line that looks like this, it's horizontal. And so anytime we have a horizontal line, it's a y equals. So this line would be y equals 4. So if we're looking for one that's parallel to that, it's just going to be a line that goes through negative 12, 9. So the y value of that is 9. So we just say y equals 9 would be that graph. For the one here, what I do is I would find the slope, which is a negative 1, 2 over 1, negative 2. And then I would use this point, negative 4, negative 6. And those are the numbers that I would use to go through my point-slope form here. So it all goes back to the point-slope form and changing it from there. So you use that, and you will get that through using that point-slope form.